Hi everyone. In this video, we are going to discuss IPv6 default route. So we have discussed in IPv4 default route that if, for example, if we have a network here and these both of the computers are on the same network, they are in the same subnet, and if the destination machine or destination host is on the same network, then the packets are delivered using local media and we don't need any router. So because if they are in the same subnet, then they can directly exchange the message and we don't need any router in this case. Simple. But if the host machine wants to communicate with a host that is outside its own local area network, then of course we need a router because we need to route the packets from one subnet. So in this case, this is one subnet, and maybe we want to route our packet to some other network to this. So we need router in that case, and in that case, these host machines contact a router, and that specific router is known as default router or default gateway. So in our case, this router, you can see here, this is written, this is default gateway. So this default gateway is needed when these client machines want to communicate with the client which is somewhere else in some other subnet. Now in IPv4, this default router is either configured or learned through DHCP server because we need information about this default router and we can manually configure it, or we can get the information about default router using DHCP server. So this was about IPv4. Now, how to get the same information in IPv6? So to get the same information means to get the information about IPv6 default route, what we do, there is a protocol that is a neighbor discovery protocol, and that protocol helps us to find out the default router. Now, neighbor discovery protocol itself uses ICMP version 6 messages. So it means these are ICMP messages. Just let me draw like this. So these are messages. There are some fields. So this protocol, NDP itself uses ICMP messages. There will be some particular fields, number of bits, okay? And in that message, specifically, there are different kind of messages for different purposes, but we will be using one of the messages that is a router solicitation. And for router solicitation in this ICMP message, there will be a type field. In that type field, we will have 133. So this will define that this is the router solicitation message. So one of the messages is router solicitation message, and the second message is router advertisement message for ICMPv6 type 134. So now type in the type field, this will be 134. So by using these two ICMP messages, we can find out the information about the default router in case of IPv6. So we are discussing IPv6. Now, what happens during the first message, that is router solicitation? So during the first message, the client machine, so for example, this machine needs the information about the default gateway or the default router, which is actually this. If this client machine needs information about the router, then it sends a message, that is ICMP message, specifically router solicitation message. And this client machine will use a multicast address, that is this ff02::2. By using this multicast address, this client will ask all the available routers on the network. So because the scope is link local, so on the same link, not these routers, on the same link, whatever routers are available, it will ask every router to introduce themselves. So in this way, host can actually learn about all the routers in the subnet by using this router solicitation message. For example, in this case, this host machine will ask this router that please introduce yourself or give me information about yourself so that I can use you as a default router. So router solicitation, a message which is sent from the host machine to all the routers on the subnet to get the information about those routers. So the purpose or the functionality of the first message has been done. And in the next message, that is router advertisement, simple. Now the routers will introduce themselves to these client machines or to these host machines. So now this is the turn for the router. Routers have to advertise themselves, which are available on the same subnet. So what happens? Router advertisement message contains the link local. So it may have some other information as well. In router advertisement message, we can have further information, but at least they have the link local IPv6 address of the router. And at the moment for this host machine, it needs the default router information, and this is enough for that. So for our purpose, this router advertisement message is going to convey the information about the default router to the client. So this information will go to the client. And for that, the router actually can send back that router advertisement specifically to that host machine, or this can also use a multicast address, and that multicast address is actually it actually indicates that is for all IPv6 nodes. It means not only this host machine, but all of the host machines on the link can receive the router advertisement. And in that router advertisement, for sure, the link local address is there. So all the host machines on the subnet will have the information about the default router. So simple. If a client needs this information about the default router, it uses ICMP message, that is a router solicitation. And when the router responds back to the client, it uses router advertisement message. And after the exchange of these messages, the client will have the information about the default router. So this is the way by which IPv6 works to find out the information about the default router. So yes, so I mean this was the simple introduction about IPv6 default router, how to get that information. And yes, I hope this simple discussion was a bit useful for you. And thank you very much for your time.